Hi, I'm Bill Acorn. I'm the founder and principal engineer of Acorn Consulting Services. We're a firm that provides project consulting, peer review, forensic analysis, and expert testimony to clients involved in disputes or evaluations of the built environment. We're going to talk to you today about what we do and show you some examples of those kinds of projects. So the first project that I'm going to talk to you about is a very interesting project, at least was for me, involving a $500 million fire that occurred in a semiconductor plant in Taiwan. I was retained by the largest architectural firm in Japan that was being sued by their client and also by the insurance company that paid the claim for $250 million. This was very complex, not only from a technical perspective, but from a logistics perspective. We had a Japanese client, a Taiwanese manufacturing company, an American insurance company, and American attorneys, and of course an American forensic engineer. What I found after 2 years after the fact, I was brought in and found the source of the fire ignition and also why the fire occurred, and was able to pin the blame, if you will, on the plaintiff who improperly operated their facility, and basically we had a very favorable outcome for my client. The next project I'd like to talk to you about involved a large air handling system at a university laboratory building. This is a kind of a unique design, and as a result, it involved some rather unique analysis. The air handling systems that you see here are about 12 feet tall, about 40 feet long, so very large equipment. What I found was the air handling system was improperly designed by the manufacturer, didn't take into account turbulence that was created by the inherent design, as you kind of see in this diagram, causing high velocity turbulent areas in this heat exchanger, which consists of very thin layers of aluminum that vibrated to the point where the metal fatigued and the metal sheets failed, as you see in this picture. The next project will be a medical products facility, a manufacturing company in California. I was brought in after 2 of their manufacturing clean rooms failed to function properly, and this time they asked me to evaluate the design prior to construction and prior to bidding. So this is one of those projects that's kind of a pay me now, pay me later type of project. I love to do proactive peer review, design analysis to help clients stay out of trouble. The analysis I did showed that the air handling equipment that the engineer had selected wasn't going to function properly. On top of that, they had a very complex duct system. As you can see here, the green is return ductwork, the blue supply ductwork. I recommended that they not build this facility and that we hire a new engineering firm that I would peer review. And we came up with this much simplified duct distribution system that not only saved a tremendous amount of money, but also performed properly. The next project I would like to talk to you about is involved a very sad situation. A young man died in a fire and explosion at a home in Arizona. Very unusual circumstances. We had to determine what caused the fire and why did it happen. What it turned out is the gas furnace that was in the attic of the home was installed in such a way that it was immediately on top of the gas line that fed the gas to the furnace. The furnace was installed improperly. The furnace and air conditioning system was installed improperly such that condensate from the drain pan on the furnace and the evaporator coil dripped onto the gas line, and after a period of years actually caused corrosion of that gas pipe that leaked gas into the attic space. When the furnace started the next time, it blew up. And as you can see, there was total destruction of the home. Again, unfortunately, a young man died. But the determination of how that happened was quite complex and required a lot of CAD analysis to prove to a trier of fact exactly what had happened. The following project involves a rather unique situation involving large PVC piping in a manufacturing plant that failed in a very strange way due to water hammer. You've probably experienced water hammer in your home. If you shut off a valve too quickly, you can get a vibration in the piping. Well, when you shut off a valve too quickly in very large piping, especially brittle PVC piping, it can cause catastrophic failure of the piping. What we found was that the piping components and the filters and strainers weren't properly constrained, which allowed the pipe to deflect, broke the pipe, and injured a man quite severely. This next project is kind of a fascinating project. It involves the largest laser facility in the world at the time of its design and construction for the Lawrence Livermore National Laboratories, known as the NIF facility, the National Ignition Facility. It involved 2 clean bays, 300 feet long, as you can see, and 50 feet wide each one, and very powerful lasers that focused at a sphere 10 meters in diameter, aluminum sphere, 10 meters in diameter, with the hope to do fusion. The challenge on this project, I was brought in during the construction because they were determining that the environmental control requirements of the facility, temperature, humidity, vibration, and acoustics, were not being met. So I was asked to evaluate, and here's a section through it. You can see the clean bays on either side of the capacitor banks. I was asked to analyze the air handling system and determine what could be done to improve the performance. Well, these were very complex air handling systems. In fact, what I had to do was take the drawings and kind of butterfly them, if you will. These air handlers were on 2 levels and not immediately obvious how they functioned together. Well, the truth is they didn't function together very well. So I evaluated the pressure hierarchies throughout the air handling units, the acoustical performance. We ran tests and determined that they could be simplified and allow the system to perform better. We also evaluated the air distribution through the clean bays. This is a section through the clean bay. And this very simple diagram shows that the air parted in the center, creating a very low airflow in the middle, high airflow on the periphery, which is counterproductive to good temperature and humidity control. So for a variety of reasons, this facility was destined not to work properly, and unfortunately I wasn't called in prior to construction, but during construction. We did make some changes that did improve it. However, again, in that pay me now, pay me later, it would have been much simpler to fix it on paper than it would be to fix it after the fact. I want to thank you for taking the time to watch our video and to learn a little bit about the services provided by Acorn Consulting. I'm always available to consult on a project, even if it's not something that I ultimately wind up being engaged in. I'm happy to give advice and offer suggestions. I think that our firm is very proactive, and you'll find that working with Acorn Consulting can be a very rewarding and beneficial opportunity.